Can you see my slides?
Yeah, it's visible.
Yes.
Cool. So I'm the last one.
Woo.
So today we are going to speak about distributed tracing with Lambda and step functions. But first I will introduce myself. My name is Vitaly Kheifets. I am senior backend engineer. I am around 3 years in Chegg, and I am a EOM member. A little bit about the EOM team. We are part of the e-commerce team. We are responsible on the new order post-processing flow, order life management, and the renewals flow. The agenda for today, I'll speak a little bit about the distributed tracing, then about step functions, and then I'll speak about our step function use case and our implementation of distributed tracing in step functions. But first, let's speak about distributed tracing in general. So the problem that we are trying to solve is we want to query the logs of one, let's say, execution or one request across multiple microservices. So the solution for this is actually trace ID. The first service A, will generate the trace ID, and it will log every log message that will contain the trace ID. And then when it will send a request to service B, it will send the trace ID in a header, let's say it's a REST service, and service B will log all the logs using the trace ID also. And the same thing for service C and so on. The end result is when we want to see the full picture of the full execution, we can query based on the trace ID. By the way, trace ID should be unique. For that example is 1, 2, 3, but 1, 3 will not work for real life. But that is that's what we want to achieve. A little bit about step functions in general. So step functions are visual workflow service for the AWS components. For example, it can trigger AWS Lambdas. It can send messages to SQS, to SNS. It can handle errors. It can, if something is failing, it can handle the retries. It can do parallel processing, and it can even do async processing with callback. For example, if we want to process some, let's say, 2 Lambda executions, and then we want to send that event to external system, step function can wait up to 1 year to get the response and to continue working on the same task, etc. Actually, step function can do much more. You can read about it. So to develop a step function, to create a step function definition, behind the scene, it's a huge JSON file. But in AWS, we have a studio, and we can just drag and drop the specific component we want to trigger. For example, that is a simple flow that includes Lambda. And then after that execution, it will choose if the account is active. If the account is active, it will go left to write something to DynamoDB and to send a success email using SNS. If the account validation is failing, it will just send a failed email and it will fail. And for every execution, we have something like this. The green squares will show the exact component and in the exact order that they are triggered. Here we can see that the account was valid. In every step, we can see the input and the output of the step. And for every step function execution, while we are executing the step function, we are sending a JSON payload to begin with. So let's speak about our use case. So as part of Mule decommission project, we had actually we still have, but we are working on it, a huge mule service called Commerce Event Orchestration Layer, or we are calling it COL, that reads messages from an SQS, and based on the event, it will trigger a series of actions. And it contains lots of integrations with like REST services, external services, few databases, SQSs, complete mess. So we decided to move it to Lambda functions and step functions. So the new architecture looks like this. We have a gateway Lambda that will read from an SQS, and based on the payload of the event, it will trigger the relevant step function. For example, for event X, it will trigger like the first step function that we see on the right, that will trigger two Lambda functions. Then it will write something to an SQS, and it will trigger another Lambda function. If we'll get an event Y, it will trigger the second one. Actually, we have around 70 events. We will aggregate few events to like one step function. We will have around 50, 20 step functions in the end. So what was the challenge actually? To have an end-to-end tracing per event, and to integrate distributed tracing with Lambda and step function. And our solution was to use trace ID across all Lambda functions. So if you remember, we are triggering a step function with an initial like payload. So in every step function execution, we are adding a trace ID to the payload that maybe in some cases generated by the gateway, or it will receive it in the event itself. And every Lambda execution will get that trace ID, and in the infra of the Lambda, we will actually, the logger itself will print every log statement with the trace ID. And I can give you an example that is actually from our services. We are querying based on trace ID. We can see that in every log statement, we can see the trace ID, and in the left, we can see that 4 Lambda functions were involved in that transaction. Actually, it is helping us very much to find issues in the system in real time. So if you can actually take one thing from that presentation is use distributed tracing across your system to help you when you need it the most. Thank you. If you have questions, I'll be happy to answer.
That was quite amazing, Vitaly. If anyone has any question, they can shoot it up here. We still have 2 to 3 minutes to take up questions. All right, I see everyone is quite satisfied with what they learned. We can still share slides with them over the Slack channel. We will do. So that was the end of all the speakers that we had, and all of were amazing. And I hope everyone got to learn a lot from them. Like it did add to our fruit basket a lot of new fruits to carry from here. So thank you everyone. Thank you to all the speakers who were present here. Thank you to all the audience members who were there. So yeah, that's a wrap for DevOps Con for this year. Thank you everyone for being a part of this.